7.3 is function operations. You guys have done this before. This is a lot of review of what we look at as direct substitution. What I want you guys to see here for today is kind of something like this. F of x is 2x. G of x is x minus 3. What is f of 3? What is g of 7? What is f of pi? What do? You remember?
Yeah.
What?
Like the 3 is like the, for the f of x, you start with 3 and 2x.
Oh, what am I substituting in for 3? What do I put that in for? The x. You guys vaguely remember this?
Yes.
Function notation? It's nothing more than substitution. What this is telling us to do here, is take the f equation, and wherever I have an x, I'm going to put a 3. So I put a 3 in here, and I get 2 times 3, otherwise known as 6. All right? You've seen this before. G of 7, which equation you're going to pick, the f or the g? Gee whiz, you're right. So you wind up with 7 minus 3, otherwise known as 4. Okay. Now, literally. Excuse me. I'm sorry, guys. I really am. F of pi.
That was pi.
That's not, felt like being fancy. That's pi. So you get 2 pi. And no, it doesn't say s. It just says pi. Let me get pi here.
Do you say 2x's?
Pi, isn't it? Yes.
What I'm talking about? I'm talking about real pi.
You don't say it's 2x's.
Yeah, see,
Two X's.
wait, why don't we say that? Why don't we say
Because it's
See?
the variable.
There's 2 pi.
No, it's really fun, actually.
I may not feel great, but I still have somewhat of a sense of humor. All right. So this function notation isn't anything new from what you've seen in the past. Function notation and what we're going to work on here today between 7.3 and 7.4 winds up being stuff you will see quite often on ACTs. I know that, we'll get to it later. I don't want you to write any of this down. What I'm showing you guys here is that what we're going to look at is new ways of creating functions. It's called combinations. It's literally direct substitution. If we're going to take something where we have f of x is 2x and g of x is x plus 1, and I want to create a new function with them, all I'm doing is this. Well, 2x plus x plus 1 equals what? Can this get any easier? It's that literal. What's going to be weird with some of these things is that you have to worry about explanations. You have to do things like that. Sometimes when you're combining like terms, you have to be careful with the way some of the stuff sets up. It is not difficult at all. All right. Same thing goes for, we might as well go right into fractional exponents. If I'm going to have two values, f of x is 2x to the half, and g of x is negative 6x to the half.
You want to start this?
Yeah, because I'll show you how this is going to work. The difference between what you guys were doing last week and what we're doing today is that they're starting off the problems one step earlier. They're saying f of x plus g of x, as opposed to writing it out like this. Instead of starting with this right off the bat, they're making you write it down. That's the only difference between what we did last week and this one. So what's 2x to the half plus negative 6x to the half?
Negative 4x to the half.
Very good. And there's nothing else you can do. You're just simplifying, combining by terms. Does that make sense, guys?
Yeah.
This is how I roll. When you're working with subtraction, same idea. You're just writing it out. 2x to the half minus negative 6x to the half. Yeah. And this is where you guys screw up. You forget about subtracting negatives. Like on your test, there was a problem that you had to distribute a negative to that most of you guys screwed up. It would be the top page, second side, the one on the right, I believe. I forgot what number it is. 5? Yeah, most people didn't distribute.
Oh, I did.
Does it change when you're multiplying and dividing?
No.
No. Excuse me. When we're multiplying and dividing, this is where you have to just pay attention with your exponent is that when you multiply and divide out, remember when you have same base, different exponents here and you're multiplying, you just add your exponents together. When you're dividing, you're playing that game of war. All right? It's no different than what you were doing last week, except you have to write down the problem first. That's the only difference.
Why do they do that?
Great.
Why do they make it so that you have to write down the problem, just so you learn function?
Yeah, it's helping you learn about function notation because when we talk a little bit more about function notation towards the end of the hour, we talk about 7.4, we're going to look at inverses of functions. And that's where the function notation it comes in real handy. All right? Composites and stuff like that. So in this case here, I had the same base with different exponents and I'm multiplying. What do I do with my exponents? Switch your, yeah. So you went up 3x to the 5/4. Were you okay with that?
Wait, how do you get 5 again?
I'm sorry, I was copying into here.
How do you get 5?
1 plus 1/4. See how I have the same base, different exponents?
I thought you changed that to 4.
Yep. So you get 3
Oh.
x to the 5/4. And then when you're dividing them, you play the game of war. And who's going to win?
Top, so 3x.
Yeah, exactly. You just went with 3x to the 3/4. And like I said, this is nothing different than what you were working on the past week or so. Do you agree with me on that? The weirdness comes in when we start to do things like this. Compositions. Composition of functions just look weird because it takes a while to get used to what it looks like. Let's go back to something really easy again. What was it? F of x was 2x, and g of x. What did I have? X minus 3?
Yeah.
All right. Let's go back to something very, very, very easy. Let's look at something that's linear. And I'm going to talk about the composition. Composition of functions is just the molding of two functions together. And it looks like this. F of g of x. F of g of x.
It's not that bad.
Because what are you doing?
You're just substituting that for
Right. It's all you're doing. You're taking what this says is what is f of g of x.
So you're substituting.
You're taking the g of x equation,
Oh, and then you're, okay.
substituting it in to here.
It just looks weird.
It just looks weird.
Wait.
So it's G of X.
The way I word it a little bit differently here, and sometimes it's pretty helpful.
Okay, but G of X and 3.
And I'm substituting that in for x. So here's what you do. Take your g of x equation, you write it down, and then you surround it with the f equation.
Isn't that
And so
one
where's the X? You
Right.
substitute
You're taking this in.
Oh, because, oh, you said, okay.
F and then
Okay, I got it.
Instead of saying number, you're saying G of X. The equation G of X.
Instead of it being f of 3, be 2 times 3, because you put 3 in for x, right? Now I'm saying take the g of x equation and put it in for x. That's all.
Like we're done.
I'm literally taking this value and substituting it into here.
That all makes sense. That all like makes perfect sense. But you think that they're like here's a different variable because they're saying that x equals x minus 3.
Yeah.
I mean, it all makes That's sense. why I'm.
It's
confused
not,
because they're
it's
saying
not
that X
saying that
equals
x is equal to x minus 3, it's saying that there's a
Like
function.
whatever you put there. Yeah.
It is. I'm taking, I'm literally taking this equation, because that's what it's telling me to do, and substituting there for x. So if I want to do g of f of x, I write down the f of x equation, and I surround it with the g of x. Because I took this value, f of x, and I substitute it into there. Sometimes I can simplify, sometimes I can't. I can't simplify it. Okay? Whereas in the first one, I didn't take it a step further here. Could I have rewritten that as 4x minus 6?
Yeah.
Yeah, that's what you should
Wait,
have
no,
done.
2x minus 6.
Math is hard.
You're right.
Why do you think I
Just announce your
have
We all care so
All right.
much.
So when you're working with
Trying to get a
when we're working with these things, it doesn't change when you have different values. You are literally writing down the interior stuff and surrounding it with the other function. Okay? Don't get to it. It's not that bad. So if I have two functions, f of x is 3x to the negative 1, and g of x is 2x minus 1. If I want to figure out what f of g of x is, I start by writing down the g of x equation, 2x minus 1, and then I surround it with the f equation. Because I took that g of x equation and I replaced it with x in the f equation. And then from there you simplify. Yes, ma'am?
Right away, when you see the f of x equation, is it okay if you flip the x to the bottom just so you can plug the other stuff into it?
You don't have to, because sometimes they'll have some exponent rules and stuff like that. You don't have to worry about it. I just keep it how it is. I mean, if you
Okay.
want, you might leave something, you might not.
Okay.
You never know. So here, I know that the 2x minus 1 is not happy, so it's got to go,
On the bottom.
and that's it. That's all you can do. And you're done. Okay?
It's just 2x minus 1.
Yes, sir. Okay. Now, when I go the other way, g of f of x, I start by writing down the f of x equation, and then I surround it with the rest. What can you simplify?
6x minus 3.
Whoa.
Wait, 6x minus
Whoa.
1.
You have to
Hold on
There's
here.
I forgot the little thing.
The only thing that's being raised to the negative 1 power is x, correct?
Yes.
So this winds up with 6 over x
Wait.
minus 1.
Hey, don't say
I'm not.
Is it just 3 over x?
Yeah, I did. What's 2 times 3? 6.
Yeah,
X to
the negative-
you're right.
Yeah. You're right, Christian. What I'm saying here, the only thing that's being raised to the negative 1 power is the value of x. The rest of it just goes with the flow. Right? And then the weirdest of them all, f of x. You start by writing down the f of x equation, and then you surround it with the f of x equation.
Don't understand the desperate.
3, and 1. Hold on.
So the exponent.
Hold on. In this case here, you've got 3x to the negative 1 raised to the negative 1. You agree?
Yeah.
That's power to power then, right?
Multiply.
So you multiply your exponents. So you wind up with
3x.
Just 3 times 3x.
3 times 3 to the negative 1 times x to the first power.
Wait,
So
What's negative 1 times negative 1?
I got you.
And then 3 to the negative 1 is,
1/3.
what's 1/3 times 3?
1.
Really?
Sorry, I don't know what I was doing.
You get x. People get x.
Because it cancels out.
High five.
Makes sense, because the first one.
3 to 0. Oh, I see where you're going. I like that. Here, no, I caught my hand. Yes, sir.
If we ever have f of x times f of x, or f times f of x,
Guys, come on, please.
will it always cancel out like that?
No.
X?
Don't look. just not. It's just not. That's all it is. There are times it works, sometimes it doesn't. Sometimes you get 1, sometimes you get 6. You get X squared. It's just done. Sorry, I don't want to yell. I'm just like too loud. Try a couple of these real quick. I'm not worried so much about domain today. We'll worry more about domain stuff tomorrow. But the reason we use these things is that you can use what are called inverse. Yeah, I'm going to mix it. This is the 7-3 and 7-4 stuff. I'm going to mix a little bit of 7-4 with the inverse, with the function notation, as opposed to writing out equations of functions yet. Because we're talking about inverse functions. We have, what happens here is f of x and g of x are inverses of one another if and only if. Remember that? Yeah.
Oh.
I remember that. This top was trying to expand it.
It's shorthand
Yeah.
because we don't like to write things out because we're lazy.
How they got that specific.
If this happens, f of g of x
This makes me think proofs.
if that happens, where when you substitute the composite of f of g of x and g of f of x, when you simplify it out, if they both give you a value of just x, then they're inverses of one another.
So that other form might have been inverse of each other?
It could have been.
As long as you don't.
If it went the other direction, then it might have been. So what will happen here, I know I gotta quit spelling. I'm joking. That's right. For example, if I want to do something like this. Smoking?
Yeah, mine smokes like 3 packs a day. That's on a slow day.
Was it a hypocrite that smokes 3 packs a day? Song lyrics. I thought you would at least got it.
I'm sorry. What was it?
Fight for your right to party.
You gotta fight. Fight right.
So what we're going to do is check to see if these guys are inverses of one another. All right? We're going to check to see if these guys are inverses of one another. And in order to do that, all you have to do is check, does f of g of x equal x and g of f of x equal x? So we just check it out. We start by writing down the g of x equation. Excuse me. 2x minus 2. And I'm going to surround that by the f of x equation. 1/2 plus 1. Everybody see how I'm doing that? By writing it down and surrounding it with the other equation? All right. So what's half of 2? What's half of -2? Very good. What's -1 plus 1?
0.
So you get x. You're halfway there. Okay. All right?
Oh, yeah.
Okay. Do the same thing with the other one. Write down your f of x equation. 1/2 x plus 1. And then surround it with the g of x. What's 2 times 1/2?
Oh my gosh.
Are they inverses of one another?
Si, senor.
Yeah. That's what we did. You're checking to see if they wind up being inverses.
Do you have to write something? They are inverse.
There was a smiley face.
That's, they're actually, I think the instructions will say verify that they're inverses. So you say yes. What we're going to do tomorrow is a little bit different. I'm going to ask you to write out What's the inverse of that? I'm going to ask you to solve for that.
It's not bad.
It's not bad. It's actually very easy. But let me do another one of the other ones. Did I get that stuck in your head? You're welcome.
That's my thing, that's my special trait.
No. Sorry. Verify those are inverses.
I'm just blown. I never knew that.
You know, excuse and what? Excuse is one word.
Let me start this out here, see how we're doing this.
I need help.
F of g of x. So I write down the g of x equation. And then I surround it with the f of x.
Oh,
1/3 to the third power is just power of 1.
yes.
So this happens. Just becomes 1.
This happens.
Yes. 3 over 3 is 1. So you get x minus 1 plus 1, which is, okay? When you're multiplying fractions, multiply shared cross. Yeah, you get, when you do that, you get 3.
See, I just distributed it.
Oh.
And then if you had some
Oh, I get it now.
So basically, X
Alright, and then go the other direction. G of f.
It's not that bad, actually.
Our f of x equation was 3x cubed plus 1.
Man.
Oh my gosh, this is beautiful.
To that, I'm going to surround it with minus 1 over 3
This is so nice.
to the third.
Never thought seeing so nice.
Order of operations. Well, inside the parentheses, the only thing I can do first is 1 minus 1, that's 0. 3 divided 3 is 1.
And then
X to the third, but 1/3 is X.
Can you have verified inverses?
Yes, we
Yes.
betcha.
Okay. Not so bad, is it? This is beautiful. They give you a couple of these from both sections to work on for tonight.
What?
I'm sorry. Wait, are we even gonna plan with him?
Probably.
No.
Maybe.
We would know if you.
Absolutely.
I make sure.
I'm putting this here.
Yeah, a bunch of sophomores are there.
Yeah, because we get our letter and then we
Yeah.
out.
Ouch. You get a patch this morning.
Where are you at?
On the, one thing we didn't talk about on, for the inverse stuff, when they're looking at some of them, they're trying to make your domain be positive. The reason that they do that with, when you're working with even powered exponents, because obviously if you take a square root of both sides with an even powered exponent, you get plus minuses. When you're working with inverses, they try to tend to work with just the plain old boring positive values. That's why you're going to see that caveat in there where x is greater than or equal to 0.
Usually if it's extra domain, don't worry about it.
Yeah, don't worry about domain for today. It comes into more into play tomorrow because we're going to look at graphs and we're going to look at the actual equations. It's very easy to work with. Okay? Give those a shot. You guys, like I said, you should be pleasantly surprised at how simplistic or how easy it is.